Good afternoon to all. Uh, so,
Good afternoon, sir.
yeah, this is my Raspberry Pi. I'm accessing remotely. So, actually, we have a set of these are the application we have going to discuss today. But already we have learned the LED demonstration yesterday, right? So directly we are entering into temperature, distance, and camera. These two will be demonstrated now. Today we are going to demonstrate uh, two applications. One is temperature and humidity control. The second one is distance count, and the third one is camera. So to find the temperature and humidity, we need a humidity sensor. That is this. It has three pins. These three pins having one is a VCC. Next one is a data signal. Third one
Congratulations.
a ground.
Congratulations, sis.
So we are going to connect this to our breadboard. This is the breadboard. I'm connecting this to breadboard. This is the way I'm connecting, and whatever the three pins have a humidity sensor, I'm using this. So is this visible? Yeah. So here it is, my Raspberry Pi. I'm connecting to 2 to 1. This is a power connection voltage. We can also call it a VCC. And next we have signal, that is TX pin of your so this is the ground one. And next I'm going to connect the data data pin, that is TX pin, middle one. So this is the way we have to connect. So the Raspberry Pi is restarted. Yeah, once again, we are connecting. Raspberry Pi is restarted, rebooting again and again. So the way we are going to connect. Next, I'm going to share the screen. Yeah. CD, desktop, IoT 2. We need to run this Python. That is temp.py. I'm going to get this room temperature and humidity. Wait, one second. Should we have the? Okay, we will see the big pin diagram. Based on that, we can identify. This is the pin diagram. Here we connected the our ground, the middle one. Okay. Stop here. The ground is this one. This is the ground. Ground is the. It's not connecting the ground. Desktop. I think this is a loose connection. It's not sensing. Failed to receiving. check the code once. Okay, we should include this Adafruit. So sudo install dht. That's why it's not sensing. Okay, already we have. It has to print the temperature followed by the humidity of this room. Actually, I think the sensor is a problem. I think so. It's not receiving the signal. Failed to receive. Second. In diagram, we have like this. This is mine. No need to use the register, no problem. This is the volts input power, PCC power connector. And the next, again it restarting. I think the resistor problem. So we're connecting this later, no problem. We don't have resistor, so we are going to connect the direct camera. So how we are connecting camera, I will explain now. That is Pi camera. This is a Raspberry Pi. It has an inbuilt camera module. So first I am going to add this camera to this module. This is the Pi camera. This Pi camera consisting of a camera. It has a serial bus. So we have to connect this serial bus to your module, which is available in Raspberry Pi. So I'm going to restart the Raspberry Pi once because I have to insert this camera to my Raspberry Pi. So I have to remove all the connections to Raspberry Pi. I have to remove this case to insert the Pi camera. See here, and here we have camera port. See, it has the plug. We have to push this plug and we have to uh, add a pi camera connection. First we have to push this button and then we have to insert this in this manner, like this. We have to pull this button and push this camera in, then push it again. It's going to be connect like this. Then we're going to connect all the components. USB connection, and mouse and keyboard, HDMI connection, and followed by power connection. Okay, so if at all I want to take a, a photo, I need to take manually. How can we use manually? Uh, Rasfill, Raspi still warning O to desktop .jpg. Take the photograph like this. Okay. In desktop, we are going to find, see, ls. You can find a.jpg. This is a.jpg. So now, just now we are taking the photograph. That is this. This is the photograph. So we can take the manually. So if at all I'm taking another one, this screen, whatever the screen we have, this is b.jpg. We don't have b.jpg in a, right? So it takes the, okay, generator. Okay, one second. Now we are in a desktop window, so it's not coming. Yeah. Let us check. A.jpg, b.jpg not came. Oh, one second. Yeah, now it is came. That is, see here. This is a.jpg. Let us see. The image is like this. This is the image we have taken. So we can take a video also. The video consisting of H246. Sorry, H264. So we are going to get a video that is this. This is the video we are taking. Okay. So H264 is a codec version, and let's say if whatever the video versions we have, the MP4, MPEG, MP, MPEG format, the same as it is at a higher resolution to MPEG, that is S264. This is a video I have taken. It's going to display like this, and let us see the code. This is the manual for taking the pictures from PyCam and capturing the video using PyCam manually. So this is the service file, raspi still dot output version, option. Whatever the file you want, you can specify the right address also. Okay. So now, how can we take programmatically? We are going to know. CD camera. We have two things. One is cam pi, video pi, cam 2 pi. So first we are going to know what is the code of cam.py. Cam.py. See here we have the pi camera is a module belongs to Python. So we are importing for pi camera. For pi camera is a module. It has a class pi camera. The P and C should be capital because it's a class. So from time I'm importing sleep. So why? Because whatever the pictures we are taking, it takes some time. From that I'm creating a PyCam object, that is camera. So I'm starting the preview, that is camera.start preview. It start the capturing. It captures 10 milliseconds, and after capturing this camera, this image which stores at home by desktop cam1. So if at all I'm changing this cam1, so cam1 will be replaced if it is available. There is a image in a cam1 also. So we are going to stop the preview. So I'm executing this program, Python cam.py. So it's going to be take a picture of my program, that is cam.py. Yeah. See, in desktop we have a cam1. In desktop we have a cam1. Yeah, this one. See here, this is the photo I have taken now, right now. Our program. I have taken the program, a picture of my program. And the next we have a set of captures. Okay, continuous capture. How we are capturing continuously? That is belongs to a program that is cam2. This is the continuous capturing by using a for loop. I'm capturing 5 images, each image consisting of 10 milliseconds sleep. Average 10 millisecond it creates and stores this into pics is a folder which is available in the desktop. Here I'm replacing pic 0 to 4. So you can here I'm changing that. Here I'm using pics. Okay, once again I have any pics. Here I'm deleting all the files. So we don't have any files right now here. So now I'm executing this program. So whatever the program we have, taking the pictures, component, this Raspberry Pi, and the program which we are taking. This is monitor. And the last image. So there are 5 pictures which stores in the pics. See, in pics we have 5. What are they? See, this is the first one, second one, third one, fourth one, and fifth one. This is that we are taking the image, and next we have the capturing of video. That can be VID. So the file name is VID. It consisting of same PyCam class, and slave will be imported. We are creating object for PyCam and start previewing. See, instead of capturing, I'm using recording. That's all. Instead of capturing, here I'm using camera.capture. Here I'm using camera.start recording. So when we have start recording, we have stop recording also. So here, see, I'm storing in pics vid.h264 is a format. Okay, in this format is going to be stored. Okay, I'm capturing the a video which is the 10 milliseconds. Out of that, I'm stopping the recording and stopping the preview. See, Python, recording the video. Yeah, 10 milliseconds. 10 milliseconds video which is available here. See, this is the video. This is a video I have captured. If at all I want to capture myself, this is the video we are going to capturing by using a programmatically by using a PyCam of Raspberry Pi. So this is will be replaced with my okay. This is a video. Right. So this is the usage of the PyCam. We can implement our own security cameras in our home, in any place, any business areas. We can implement by using a Raspberry Pi with the using of Pi camera. So this is about the taking the pictures and capturing the videos by using manually and programmatically by using a Pi camera of Raspberry Pi. So next we are going to look like distance. Okay, see, distance we have. This is the sensor we are using, ultrasonic sensor. It has 4 pins. One is power input VCC pin, and the trigger pin, next echo pin, and ground pin. These 4 is connected to this. See here, the ground which is connected to your ground by using of like this. Right? And whatever the GPA pins. One second, I will show with the program. The distance having how many pins it is. One is a power, another one is a ground, another 2 are echo and trigger. The echo and trigger is a 4th pin, and echo is a 17th pin. This one, 4th pin and 17th pin. The echo is connected to trigger. Sorry, this is the 17th pin. This is the 4th pin. The 4th pin is connected to echo, and 17th pin connected to trigger. So we are going to design. So I'm removing the camera from the Raspberry Pi. We have to pull this button of camera. Yeah. Next we have ultrasonic sensor. The sensor which is connected to my breadboard like this. I'm connecting my power. That is first pin. This is VCC. This VCC connect to this first pin. So we can connect like this. And then next we have a ground. That is third pin. That is connected to ground. That is the last pin. Okay. The next is a 17th pin. That is here, the 17th pin. GPIO pin. The 17th pin is connected to trigger. That is second one. And the fourth pin, GPIO fourth pin. To your echo. Yes. Echo is here, it is echo. So we can connect in front. Okay. Next we are going to run the program. What is that? Distance, right? This is my program. Here. Yes. This distance measure dot py. See, this is object. See, nearby. My hand is nearby 4. If it is distance 20, 18, 27, 160, 19, 15, 11, 7, 3 centimeters, 8 centimeters. This is the distance calculation which is going to be calculated. I'm removing. The image is here. This is the image. Okay. 94. And it comes here. It will be decreased. 46, 45. When it push back. 90, hundreds. When I'm using my hand, 4, 5, 3, 18, 20, 40. Like this. Okay. This is the way we are going to find the distance. Cat distance program. This is the program where we have, see here, we are importing GPIO. Next we are importing the time. Next we are setting the time mode as BCM. Our trigger is 4. Our echo is 17 because it has the VCC power input followed by trigger followed by echo and followed by one ground. So these two are important, trigger and echo, and it finds the distance of any obstacles which is in front of the sensor. Okay, here I'm defining one function, that is distance. Here I'm setting the trigger true. So if it is true, it calculates and sleep 0.0001 microseconds. Okay, next false, and we are getting the start and stop time, and we are calculating the difference time while we are getting the echo, whatever the echo we have. So start time and end time. Okay, we are finding the time elapsed, stop time minus start time, in between time, and by we are dividing by 2. Okay, by using up time elapsed into 300 by 2. I'm returning the distance. That's all. So it returns the centimeters like this. 7 only. I'm not moving my hand, right? 7 only. 5 only. See, my hand is not recognizing. Now it is recognizing. Otherwise, it's take the chairs. Obstacle is chair then. But I'm using my hand here. See, 55, 52, 39, 37, 29, like this. Okay, this is about the distance calculator program, and these are the hands-on sessions of the Raspberry Pi. So we have discussed the LEDs and or like a traffic light signal, and one is distance vector and the camera, Pi camera. So these are the, we have plenty of applications we can implement it by using a Raspberry Pi. Okay, so as it is a virtual EDP, so we are conducting only some of applications. Okay, so we have a plenty, we have a much more applications which can be developed by using a Raspberry Pi, by using a Python programming. So this is about the session today. Okay, anyone having doubts, please you can ask doubts.